geobyte.
Let us take the another important problem asking like this. A body cools from a temperature 3 to 2T, 3T to 2T in 10 minutes. That means, let this is the case one where the temperature is dropping from 3T to 2T, 2T in 10 minutes. In time period T equal to 10 minutes. The room temperature is T. Room temperature. Room temperature generally we are assuming as TR equal to T. Assume that Newton's law of cooling is applicable. The temperature of the body at the end of next 10 minutes will be. That means in the case 2, in the next 10 minutes, temperature is falling from right 2T. Already the temperature is dropping from 3 to 2T. Then in the next 10 minutes, 2T to some X value. You don't know that value. That X value you need to find it the next in the next time period is equal to 10 minutes. For this case also room temperature equal to T. Okay. As you know, the rate of change in temperature that is right dt by small dt equal to k into T minus room temperature. Okay. From this I can write that case 1. Let us take the case 1. Case 1 T1 minus T2 divided by time period T equal to, here T is the average temperature. This is the average temperature. Average temperature T1 plus T2 by T minus T into K into K. Here T1 is 3T. This is the T1. This is the T2. Here 3T minus 2T divided by time period given 10 is equal to 3T plus 2T by 2. This is 2 minus T into thermal conductivity. Let us take another slide. Here 3T minus 2T by 10, that is T by 10. T by 10 equal to K into, it is 3T plus 2T, 5T by 2, 2.5T, 2.5T minus T, minus T. Okay. It is T by 10 equal to K into 1.5 T. From this K equal to, of course, this T is cancelled. K equal to 1 by 10 into 1.5 equal to 1 by 15. That's the K value. Okay. Now let us take the case 2. Case 2, right? 2T minus X by time period is 10 equal to 2T plus X by 2 minus T into K into K. Okay, now let us simplify it. 2T by 10 minus X by 10 equal to 2T by 2T by 2 plus X by 2 minus T minus T into K value 1 by 15. 1 by 15. Okay. Now you bring this 15 to left side. It is 15 into 2T by 10 minus 15x by 10 equal to 2T by 2. 2T by 2. 2T by 2. Oh, nothing but T only. T plus x by 2 minus T. Of course, here T cancel. T cancel. Finally, it is 30 T by 10 minus, otherwise you bring it to the other side, x by 2 plus 15 x by 10, right? Here it is, 1.3 t equal to 1.3 t equal to 1.3 t. Here it is 15 at 8 minute. 15 into t 30. Should be very careful. 15 into 2 30. Okay. Now it can be written as 30 by 10, 3t. 3t equal to, let us take LCM. Here it is at 10, 5x plus 15x. Okay. Here 3t into 10 is equal to 20x. 30t equal to 20x. X equal to 30t by 20. It is 3 by 2 t or 1.5 t. X equal to 3 by 2 t. Look at the option B. Option B is absolutely correct. Okay. Are you following clearly? Yes. Similarly, let us take the another important problem asking like this. Coefficient of linear expansion of brass and steel rods are alpha and alpha 2, alpha 1 and alpha 2. Alpha 1 equal to coefficient of linear expansion for brass. Similarly, alpha 2 equal to coefficient of linear expansion for steel, and length L1 and L2 are the length of the brass. L1 equal to length of brass, L2 equal to length of steel. If L2 minus L1 is maintained the same at all temperatures, L2 minus L1 maintained same means change in length maintained same at all temperatures in both brass and steel. Which one of the following relations hold good? That means here change in length of the steel equal to change in length of the brass at all temperatures. At all temperatures. Because he wanted to maintain same temperature difference, same original temperature difference at all temperatures. All temperatures. Okay. Delta L1, delta L equal to for steel. Steel it is alpha to L. I mean, it is like this. L alpha delta T for steel equal to L alpha delta T for brass. Okay. So here for brass, first let me write it. Brass length is given L1. Okay. L1 alpha 1 L1 alpha 1 delta T for brass equal to L2 alpha 2 delta T for steel. But delta T for steel equal delta T for brass. Then L1 alpha 1 equal to L2 alpha 2. That is condition. L1 alpha 1 equal to L1 L2 alpha 2. Option D is absolutely correct. Okay. Similarly, let us take the another important problem asking like this. A piece of ice falls from a height h so that it melts completely. Only 1/4 of the heat produced is absorbed by the ice, and all energy of ice gets converted into heat during its fall. The value of the height, it is given like this. There is a piece of ice. This is the ice. It is available. This is the ground level. This is the ground level. With respect to that ground, The piece of ice is available at a height of h. Then ice is available with an elevated height. Therefore, it is maintaining potential energy mgh. But only one fourth of ice it is given. Only one fourth of the heat produced is absorbed by the ice. That is the potential energy is converted to heat energy, that is equal to heat received by the ice during the melting, that is m into L, that is the latent heat which is given. Of course, G given. This m is cancelled. Finally, it is equal to GH by 4 equal to L, or H equal to 4L by G. 4 into L means here not length, latent heat. 3.4 into 10 power 5 joules per kg divided by 10. But look at the options. It gives in meters. To get in kilometers, it should be divided with 10 power 3. Then 10 power 4 will be cancelled. Here it is 1. Finally, it is equal to 4 into 3.4 into 10, 34. 34 into 3 equal to 136 kilometers. That is the answer. Look at the option C. Option C is absolutely correct. Understood clearly? Yes.
Geobyte.